guys. Today I'm excited to show you something really fun and interesting. We are going to build an emoji catcher game using React. So, let's check out the output of our emoji catcher game. As you can see, we have got a nice welcome screen with instructions. It's pretty straightforward. Your goal is to catch the emojis by clicking on them. Each emoji you catch gives you points. But be careful, there is a bomb emoji, and if you click it, the game is over. You can also see the difficulty levels, easy, medium, and hard, which you can choose before starting the game. Now I will select easy mode and start playing. Let's see how it goes. See here, when I click on each emoji, it's adding a point, and you can see the score increasing. Let's see, we may win the game or not. Oh, see. The timer is at 17 seconds, and we are still at a score of 10. Will we win or not? Let's find out. Oh, we are in hurry. Let's catch the emojis fast. There are 7 seconds left, and we have a score of 21. Oh no! We clicked the bomb emoji, and now we are out. Here we have play again button. Let's click it and play again. Yes, we are left with 9 seconds of time. Let's see, are we gonna win or not? More 2 seconds left. Yes, we won the game. You can see the congratulatory message in green, showing our score, and there are confetti animations with papers falling. It's so satisfying, right? Now let's start building the game. First, create a new folder and name it anything you like. Give any name, like I gave a name emoji. Once you've created the folder, drag and drop it into your versus code to open it there. Now, it's time to set up our project. Open the terminal in versus code and type this command npm create white at latest with a project name. Emoji underscore catcher underscore game. And now hit enter. Next, it'll ask you to select a framework. Use the arrow keys to choose React and press enter. Then, it will ask you to choose a variant. Select JavaScript. The setup process will begin, and once it's done, navigate to your project folder and install dependencies by running. Type npm install and hit enter. Alright, while our dependencies are getting installed with npm install, let me quickly explain what's happening. Basically, this command is downloading all the necessary packages and libraries our React project needs to run smoothly. It's like bringing all the tools and building blocks to start creating our app. Sometimes it takes a little while, especially if your internet is slow or if there are many packages to download. But once it's done, we'll be all set to start building and writing our code. Let's also install a couple of extra packages we'll be using in our project. Type npm install FramerMotion React Confetti. We'll install FramerMotion for adding cool animations and React Confetti for the celebration effects when we win the game. To do that, we'll just type. This will download and set them up for us, so they're ready to be used when we need them. It's always a good idea to install everything we need in time, so we can focus on building the project smoothly. Now open src folder and create a components folder inside src folder. Now click on components folder and create a file named emojigame.jsx. Again click on components folder and create a file named emojigame.css. Here you can see all set correctly what we need. Now, open the app.jsx file, delete the present code and let's start fresh. Type import React from React. Then type import emoji game from .components emoji game. This line import the emoji game component from the emojigame.jsx file located in the components folder, so we can use it inside our main app component. Then type app.css. This line imports the app.css file, allowing us to apply custom styles to our React app for better visuals and layout. Const app equals to open bracket and close bracket equals to. This line creates a React component called app. It's like a box where we put all the things we want to show on the screen. Return open bracket. Here, we are telling React what should be shown on the screen. Div. We are making a box, div, to hold our game. It's like a container to arrange everything properly. We are adding our emoji game component inside the box. It's like placing the game inside our app, so it can be displayed. Then export default app. Now open main.jsx file and delete present code completely, and we start fresh. Import React from React. This line is like calling React to join our project. It helps us build cool user interfaces. Import React DOM from React DOM client. React DOM is the part of React that handles showing our app on the browser screen. Import app from .app. We are bringing in the app component we made earlier, so we can show it on the screen. Import .index.css. This is where we bring in our styles, colors, fonts, etc. to make our app look good. React DOM.createRoot, document.getElementBead, root.render. Here, we are telling React, hey, find the spot with the ID, root, in our HTML and put our app there. React.strict-mode. This is like React's way of double-checking our code to make sure it's clean and not doing weird stuff. App. This is where our app component shows up on the screen. It's like putting our whole game there. Or React.strict-mode. We are just closing the double-checking mode. Our main.jsx code setup is complete. Now let's start our main code where we build our layout structure and styling of our game. Type import React useState from React. It is used to bring React's core library and the useState hook into your file. Now import emojigame.css. It is used to include styles from the emojigame.css file into your React component, making the styles apply to that component. Const emoji game equals to open bracket close bracket. This is our main game function. Think of it as the brain of our game. We start with our instruction page structure, so write that code here in this. Const show instructions, set show instructions is equal to useState, true. Creates a state variable show instructions with the initial value true, and set show instructions is a function to update its value. Const restart game is equal to the set show instructions, false. This defines a function named restart game, which is triggered when the user clicks the start game button. It updates the state show instructions to false using set show instructions. Setting show instructions to false hides the instructions from the screen. Return. This begins the rendering part of the component, returning the JSX structure to be displayed on the screen. Everything within this block will be what the user sees when the component is rendered. The parentheses are used to group the JSX code for better readability. Div class name is equal to game container. This creates a div element that acts as the main container for the game. The class name game container allows styling to be applied via the emoji game.css file. It helps keep the content organized and ensures CSS styling is applied properly. Go show instructions and. This line uses conditional rendering to check if show instructions is true. If true, the content inside the parentheses will be displayed. If false, the instructions will not be displayed on the screen. Div class name is equal to instructions. This creates a div specifically for holding the game instructions. The class name instructions is used to style this block of content. It ensures the instructions are visually separated from other game elements. H2 Welcome to Emoji Catcher Game, or H2. This displays a heading with the game's title. The H2 tag is used for important titles, making it larger and bolder. It helps the user quickly identify the name of the game. P Instructions, or P. This adds a label to indicate that the following text will be instructions. The P tag creates a paragraph element, typically styled as plain text. It provides a clear section header for better readability. Ol. This starts an unordered list, which is used to display the instructions as bullet points. Helps in organizing multiple pieces of information neatly. Each instruction is added as a list item, Li within this list. Li catch emojis to earn points. Li displays the first instruction of the game. Informs the player about the primary objective of the game. The Li tag ensures it's displayed as a bullet point. Li avoid clicking the bomb emoji or you lose. Li. This instruction tells the player to avoid clicking the bomb emoji. It adds a challenge to the game, making it more interesting. The use of the bomb emoji helps the user quickly identify what to avoid. Li win by scoring the required points before time runs out, or Li describes the win condition for the game. It explains that the player needs to achieve a specific score within a time limit. Prepares the user for the upcoming scoring instructions. Li easy, 25 points vertical bar medium, 40 points vertical bar hard, 60 points. Li lists the point requirements for different difficulty levels. Provides clarity to the player on how many points are needed to win. Uses text formatting to keep the instructions clear and concise. All. Closes the unordered list. Ensures all instructions are grouped together visually. Makes sure the list structure is correctly displayed. Button on click is equal to restart game, start game, button. Creates a clickable button labeled start game. The onClick event is connected to the restart game function to start the game. When clicked, it hides the instructions and proceeds to the gameplay. A div closes the instructions div block. Ensures all instructional content is properly wrapped together. Allows for specific styling using the instructions class. Closes the conditional rendering block. This ends the condition where instructions are displayed only when show instructions is true. Important for managing what is shown to the user based on state. A div closes the main game container div block. Ensures all game-related content is properly wrapped together. Makes styling the entire game section easier. Ends the return block of the component. The JSX code structure is completed here, ready to be rendered. You can see the output which has all the instructions details. We need to add styling to it to make it look more beautiful. All the instructions details we added in our JSX code was here appearing perfectly. Now open emojigame.css file to add stylings to our structure. Body HTML times this code block styles the entire web page by removing all default margin and padding, setting the width and height to cover the full screen, and preventing scrolling. Times the background color is set to a light blue shade using the hex code #F0F8FF. Times it uses flexbox to center everything horizontally and vertically within the browser window. Times the font is set to Poppins, giving the text a modern and clean appearance. Times see the output. The entire page has a light blue background, and everything is centered perfectly on the screen. Game container. Times the game container class creates the main area where the game content will be displayed. Times its width and height are set to occupy the entire viewport, using 100 VW for width and 100 VH for height. Times the display is set to flex with a column direction, so elements are stacked vertically. Times it aligns items to the center horizontally and starts them from the top vertically. Times see the output. The game layout is nicely centered with elements arranged vertically. Instructions. Times this is the stylish container for showing game instructions. Times it has a width of 60% of the screen with a maximum width limit of 800 pixels, so it looks good on all screen sizes. Times the padding of 40 pixels ensures the content inside has space to breathe. Times the background is a beautiful gradient transitioning from dark blue to purple, giving it a futuristic look. Times the border radius of 20 pixels makes the box's corners rounded and smooth. Times the shadow effect makes the box look like it's floating above the background. Times the sliding animation called slide-in makes the instructions appear smoothly from the top, giving it a professional feel. Times the text is styled with a soft white shade for better readability and uses the clean Poppins font. Times visual effect. You will see a sleek, glowing instruction box sliding down from the top of the screen with a smooth gradient background. Instructions H2. Times this is the main heading within the instructions box. Times the font size is large, set to 3 rem, making it clearly stand out. Times the margin at the bottom adds space before the next element, making it visually appealing. Times the text color is set to a beautiful pink shade, using the hex code #FF6BCB. Times the text has a glowing effect created by the text shadow property, making it pop against the dark background. Times the font is set to Roboto Slab, giving it a bold and elegant appearance. Times visual effect. The title, Welcome to Emoji Catcher Game, appears bright, glowing, and eye-catching. Instructions P. Times this targets the paragraph text within the instructions. Times the font size is slightly smaller, set to 1.6 rem, but still easily readable. Times the color of the text is set to a soft green shade #50FA7B, which gives it a friendly and inviting appearance. Times the font is bold, which makes it stand out from the other text. Times visual effect. The paragraph text is clearly visible with a pleasing green color that catches attention. Dot instructions ul and dot instructions li. Times the unordered list styles the game rules and instructions. Times the list style is removed for a cleaner look. Times the li items are styled with a nice gradient background of pink and light blue. Times each list item is padded and rounded with smooth corners for a polished look. Times the text is dark with bold styling, making it easily readable. Times a hover effect increases the size slightly and changes the color, making the interaction feel responsive. Times visual effect. The list items are beautifully styled, and when you hover over them, they slightly grow and change color, providing a satisfying user experience. Dot instructions button. This block of code styles the button used for starting the game. Let's go through each property. Times background color. Hush FF79C6. A stylish pink shade that makes the button look attractive and playful. Times text color. White. Provides a high contrast against the pink background for readability. Times padding. 15px 35px. Add space inside the button, making it look well padded and clickable. Times border. None. Removes any default borders, making it look smooth and modern. Times border radius. 15px. Rounds the corners, giving the button a friendly, pill-shaped appearance. Times font size. 1.2 rem. Makes the text within the button slightly larger than normal, making it readable and appealing. Times cursor. Pointer. Changes the cursor to a hand icon when hovered, indicating it's clickable. Times transition. Background color 0.3s. Transform 0.2s. Adds smooth animations when the button is interacted with, making the UI feel responsive. Times margin top. 20px. Adds some space above the button so it doesn't touch other elements. Times font family. Poppins. A clean and modern font style that matches the rest of the game interface. Dot instructions button. Hover. This block defines the hover effect for the button when the mouse is over it. Times background color change. Changes to a brighter pink shade Hush FF007F when hovered, making it look more engaging. Times transform. Scale. 1.08. Slightly increases the size of the button to indicate interactivity. Times user experience. This makes the button feel lively and fun to click, providing instant visual feedback. At keyframes slide in. This animation controls how the instruction box appears on the screen. Times from. O transform. Translate Y. 100 VH. Starts the box way above the screen. O opacity. 0. Makes the box invisible initially. Times 2. O transform. Translate Y. 0. Moves the box to its intended position on the screen. O opacity. 1. Gradually makes the box fully visible. Times effect. Creates a smooth sliding animation that makes the instructions box appear gracefully, adding polish to your interface. Now you can see the complete output, what we got here, how we styled our structure. The smooth animation is whenever we enter the page it comes with animation styling. Now we set everything perfectly. Now let's add some fun to our game by creating a list of emojis. Const emoji list equals to. To get all our emojis, just open the Google and search for emoji picker, copy and paste, and click the third link. Now scroll down and select the emojis whatever you want. Select anything you like and copy that emoji and paste it there. And also select bomb emoji, copy it, and paste it there. Like this, select any 10 emojis and paste. Then after this go down, and we add show instructions part. Now type open curly bracket, not show instructions. This line is like a condition that checks whether the instructions are supposed to be shown or not. The exclamation mark at the beginning is a way of saying, if instructions are not being shown, then render everything inside these brackets. So, The entire game area only shows up when instructions are hidden. Now, we start building the actual game area. This line displays a heading for the game. It's styled using the class name, game title, which makes it look nice and big. The emoji icons around the text add some fun styling, making it visually appealing to players. Now we check how our output got changed. Click on Start Game button, and you can see the heading we given. Now to add emojis to our heading, open Google and search for emoji, pick a copy and paste. Click on third link. Search for game emoji. Yes, we got it here. Copy this and paste it there. Now see our heading with good looking. Next, we have a section that displays the score, high score, and time left. Let's break that down. The div tag here groups the elements related to game stats. The p tags are for displaying text. The first line shows the current score by accessing the score variable. The second line shows the highest score achieved for the chosen difficulty level by accessing high scores, difficulty, meaning the high score depends on whether the player chose easy, medium, or hard mode. The third line displays the remaining time left in seconds, making the player feel the pressure of the countdown. Right after that, we have this part. Div. Label difficulty. Close tag. Label. Select value is equal to difficulty. OnChange is equal to E is equal to set difficulty. E.target.value. Option value is equal to easy. Easy. Option. Option value is equal to medium, medium, option. Option value is equal to hard, hard, option. Select a div. This section allows the player to select the difficulty level of the game. It starts with a label that says difficulty, and then a drop-down menu, also called a select element. Whenever the player chooses a difficulty level, the game will know what they selected because of the onChange function. This function, set difficulty, takes the selected value and updates it. The available options are easy, medium, and hard, each representing a different level of challenge for the game. Now, we have the game area where the emojis actually appear and fall. Div class name is equal to game area. Animate presence or emojis.map. Emoji is equal to This section creates the space where the emojis will be displayed. The Animate Presence component here helps with animations, making emojis appear and disappear smoothly. The dot map function goes through all the emojis stored in the emojis array, and for each emoji, it returns some code that creates and displays that emoji. Then, we get to the part where each emoji is rendered. Here, we are using something called Framer Motion, a library that helps us add animations easily. Key is equal to emoji.id. This gives each emoji a unique identity, so React can keep track of them individually. Class name is equal to emoji. Apply styling to the emoji, such as size, color, and animations. Style is equal to a top, dollar, emoji.y, percent, left, dollar, emoji.x, percent, a. This makes each emoji appear at a random position within the game area, giving that unpredictable feel to the game. On click. This is a very important part. When the player clicks on an emoji, a function called handleMojiClick is called. This function knows which emoji was clicked, what symbol it represents, and how many points it should add to the score. Initial, animate, exit. These three lines handle the animation. Emojis appear by growing from a small size to normal size, and disappear by shrinking down when clicked. Finally, the actual emoji is displayed with emoji.symbol. Moving on to the message display area. Message and an div class name is equal to game message. h2 message h2 button on click is equal to restart game play again button. A div. This block is for displaying messages like game over or you won. It only shows up if there's something stored in the message variable. The button here allows the player to restart the game by calling a function called restart game. Finally, we have this cool part. Shown message and confetti width is equal to width, height is equal to height. This line makes colorful confetti explode across the screen whenever the player wins. It's a simple and satisfying way to celebrate the player's success. The confetti component needs the width and height of the screen to know where to spread the colorful pieces. Oh, okay. So, we are seeing this red line or error under the word difficulty. And you know why that's happening. It's because we didn't define the difficulty state variable at the top where we declared all the other state variables. First, we add difficulty setting. Alright. So, this piece of code is defining something called difficulty settings. And what is that? It's basically a configuration object that holds different game settings for each difficulty level: easy, medium, and hard. Let me break it down in a super clear way. What is difficulty settings? It's like a menu card where we define how the game should behave depending on what difficulty the player chooses. And each difficulty level comes with 3 properties. Spawn rate: how fast new emojis will appear. Lifetime: how long the emojis stay on the screen before disappearing. Times win score: the score you need to win the game. Here's what each difficulty means. Easy mode. Easy: a spawn rate 1000, lifetime 1500, win score 25. Spawn rate 1000. A new emoji appears every 1000 milliseconds, or 1 second. So, it's pretty slow and easy to catch. Lifetime 1500. Each emoji stays on the screen for 1.5 seconds before disappearing. So, you have plenty of time to click it. Win score 25. To win the game, you need to reach a score of 25. Medium mode. Default. Medium: a spawn rate 600, lifetime 1200, win score 40. Spawn rate 600. New emojis appear every 600 milliseconds, or 0.6 seconds. They are appearing a bit quicker. Lifetime 1200. Emojis only stick around for 1.2 seconds before vanishing. Less time to catch them. Win score 40. To win, you need to score 40 points. A bit more challenging. Hard mode. Hard: spawn rate 400, lifetime 1000, win score 60. Spawn rate 400. New emojis are popping up every 0.4 seconds. That's fast. Lifetime 1000. Each emoji is only visible for 1 second. Super quick. Win score 60. To win, you need to reach 60 points. It's tough. Why do we need this? The game needs to behave differently based on difficulty. By defining these settings, we can easily adjust the game's difficulty without rewriting tons of code. It's like having a central control panel for how hard or easy the game feels. Now we add all the state variables for where red lines are appearing. Const emojis set emojis is equal to useState. This line is creating a state variable called emojis. Right now, it's an empty array because we put square brackets inside the useState parentheses. It's meant to hold all the emojis that are going to appear on the screen. The function setEmojis will be used to update that list whenever new emojis are added or removed. Const score setScore is equal to useState 0. Here, we are setting up a state variable called score and starting it off at 0. The function setScore is used to update the player's score whenever they successfully click on an emoji. Now we will add timeLeft state variable as we see here red line. Const timeLeft setTimeLeft is equal to useState 30. This one is creating a timer that starts at 30 seconds. The function setTimeLeft will be used to decrease the timer gradually as the game progresses. When it hits 0, the game will be over. Const high scores set high scores is equal to useState easy 0, medium 0, hard 0. This line creates a state variable called high scores. It's an object with 3 difficulty levels: easy, medium, and hard, all starting with a score of 0. The function setHighScores will be used to update these high scores whenever the player achieves a new record for each difficulty. const difficulty set difficulty is equal to useState medium. This state variable called difficulty keeps track of what difficulty level the player has chosen. It starts as medium by default. The function setDifficulty will be used whenever the player selects a different difficulty from the drop-down menu. Const chauvinMessage set chauvinMessage is equal to useState false. This one is called chauvinMessage. It's set to false at the beginning because, well, the player hasn't won yet. The function setChauvinMessage will be called when the player wins, triggering something fun like a confetti effect. Const message set message is equal to useState. This line is creating a state variable called message. It starts as an empty string because there's no message to show when the game begins. The function setMessage will be used to display messages like game over or you won. Import motion animate presence from FramerMotion. So here, we are importing two things from a library called FramerMotion. This library is super popular for making animations in React apps. It's really smooth and makes everything look more lively and interactive. Import Confetti from React Confetti. Now, this line is importing a super cool effect called Confetti from a package called React Confetti. What does it do? When a player wins the game, we want to make them feel excited and rewarded. And what better way to do that than showering the screen with colorful confetti? This confetti component will create that amazing celebration effect like you've won something big. And it'll make your game feel polished and enjoyable. You can see how beautifully it set our output. We didn't add our total code, so it's not showing anything. Emojis are also not falling because we didn't set it still. Let's go and do it. Alright, guys. Now, let's talk about this piece of code where we're creating new emojis and making them appear randomly on the screen. This is the exciting part where the emojis start to fall and the game actually comes to life. UseEffect is equal to. This is a special function in React that lets us run some code automatically when the game first starts. It's like setting up our game's environment. The empty array at the end means this code runs only once when the game loads. Const interval is equal to set interval is equal to 600. Here, we are using set interval to run some code again and again after a certain amount of time. Every time this code runs, a new emoji will be created and appear on the screen. For example, if the interval is 600 milliseconds, a new emoji will pop up almost every half a second. Creating a new emoji. Inside the interval function, we create a new emoji object that looks like this. ID date.now. This gives each emoji a unique ID based on the current time. It helps React know which emoji is which, even when we have a lot of them on the screen. Symbol, emoji list, math.floor, math.random, into emoji list.length. We are randomly picking an emoji symbol from our emoji list. The math.random generates a random number, and we multiply it by the length of the emoji list to get a valid index. X, math.random, into 90 and y, math.random, into 80. This is where the magic happens. We are randomly choosing positions for the emojis on the screen. The x value decides how far from the left the emoji appears. The y value decides how far from the top the emoji appears. The numbers 90 and 80 make sure the emojis appear within a certain area of the screen, not completely off the screen. Set emojis. Prev is equal to Prev, new emoji. This line is all about adding a new emoji to our list of emojis on the screen. Set emojis is the function that updates our emoji state. We are using something called a state updater function, which gives us the previous list of emojis as prev. Then, we are creating a new array with all previous emojis plus the new one. So, the new emoji appears on the screen, making emojis disappear. Set timeout is equal to set emojis, prev is equal to prev.filter, emoji is equal to emoji.id is equal to new emoji.id. Lifetime. Here, we use set timeout to make emojis disappear after a certain amount of time, lifetime. It waits for the specified lifetime, in milliseconds, and then removes the emoji from the screen. The filter function checks all emojis and keeps only those whose IDs are different from the disappearing emoji's ID. Basically, we are making sure emojis don't stay forever on the screen. They come and go, making the game challenging. Now, let's talk about the timer that counts down the time left for our game. Const timer is equal to set interval is equal to set time left, prev time is equal to prev time 0, prev time 1 o'clock. 1000. We are using set interval here to run some code every second, 1000 milliseconds. What this does is decrease the remaining time by 1 every second. But here's the smart part. It checks if the remaining time is greater than 0. If it is, it reduces the time by 1. If not, it keeps the time at 0. This avoids going into negative numbers. So, the countdown continues until the game ends. Finally, we have the cleanup part. Return is equal to clear interval, clear interval, timer. This section makes sure we stop all the timers when the game is over, or when the component gets removed from the screen. Clear interval is used to stop emojis from continuously appearing and the timer from counting down further. And the final part. Time left, difficulty. This part ensures our use effect. Function runs again whenever time left or difficulty changes. If you change the difficulty from easy to hard, for example, the emoji speed will change because we made it dependent on difficulty. So, what this whole code is doing is continuously creating and removing emojis to make them appear and disappear, reducing the remaining time by 1 every second to create the timer effect, making sure everything stops when the game is over. This code makes our game feel like it's alive and constantly moving. Now we are setting initial is equal to y minus 10. This line sets the starting position of the emoji when it first appears on the screen. The y minus 10 value means the emoji starts slightly above the visible screen area. It gives a natural falling effect since the emoji doesn't just pop into existence but appears from above. Animate is equal to y 100%. Now, this line is what makes the emoji move downwards. Y 100% means the emoji is animated to move all the way down to the bottom of the screen. So, It's like the emoji is falling down from the sky to the ground in our game area. Exit is equal to y minus 10. This line defines the animation when an emoji is removed from the screen. Y minus 10 again means the emoji flies upwards before disappearing. This happens when the emoji's lifetime ends, giving a nice effect of emojis floating away instead of just vanishing. Transition is equal to duration 1.5 is linear. This line is all about controlling the speed and smoothness of the animation. Duration 1.5 means the emoji takes 1.5 seconds to fall from the top to the bottom. Is linear means the speed of the falling motion stays constant throughout the animation. It doesn't slow down or speed up. It just moves down at a steady pace. Now see our page how emojis are constantly appearing. Now we go and style our CSS part. Game title styling. Font size 3 rem. Sets the text size to be large, making our game title big and noticeable. Margin top 10 px, margin bottom 20 px. Add space above and below the title, so it's not too close to other elements. Font weight bold. Makes the title text bold, enhancing its visibility. Color Hush FF69B4. Gives our title a pinkish color, like a cute candy shade. Text shadow 2px Hush FFE4E1. Adds a subtle shadow behind the text, making it look slightly lifted from the background. Animation Pop 1.5s Infinite Alternate. Makes the title pulse or grow and shrink gently in size, giving a playful, attention-grabbing effect. This is powered by the @keyframes pop animation defined below. @keyframes pop animation. What this does? It animates the game title by scaling it up from its original size, 1, to a slightly larger size, 1.1, and then back again. This animation continuously repeats, making the title look like it's gently popping or bouncing. Makes the game title feel alive and exciting. Score time styling. Width 80%. Makes the score section take up 80% of the available width. Display. Flex. Justify content. Space between. Uses flexbox to spread items, like score, high score, and time, evenly across the bar. Padding 10px 20px. Add space inside the box, making the text look clean and well-aligned. Background color number 333. Color white. Gives a dark background with white text, creating a good contrast for readability. Border radius 10px. Makes the corners slightly rounded, giving it a soft, modern look. Margin bottom 15px. Adds some space below this bar to prevent it from sticking to the game area. Game area styling. Width 80%. The game area stretches to cover 80% of the screen's width. Height 70 vh. It takes up about 70% of the visible height of the screen, giving us a big playground for emojis. Background linear gradient 135 deg. Hush add 86. Hush T8 BFD8. Adds a beautiful gradient background transitioning from light blue to soft pink. This gives a playful, dreamy aesthetic which matches our emoji catching theme. Border 3px solid hush DDD. Adds a thin, light gray border around the game area for better visibility. Border radius 20px. Makes the game area have smooth rounded corners, making it look stylish and polished. Position relative. Allows emojis to be positioned absolutely within this area. Overflow hidden. Ensures that any emojis moving outside the area will be clipped and not visible. What's the output? The title text will look big, pink, and gently bouncing. The score and time bar will look like a dark, clean bar with white text and rounded corners. The game area will have a beautiful, colorful gradient background with soft, round edges. What's happening here? We are setting up a timer that runs a specific function every 1 second, 1000 milliseconds. The function setTimeLeft is used to decrease the remaining time by 1 second at a time. The line setTimeLeft prev is equal to prev 0, prev 1 o'clock is a clever way of making sure. If there's time left, prev 2000, reduce it by 1. If not, just keep it at 0, 0, so it doesn't go into negative numbers. Clear interval, interval, and clear interval, timer, are called to stop those intervals from running. If we don't do this, it could lead to memory leaks and cause a game to act weirdly or even crash. We were playing around with the X and Y properties to make our emojis move up and down on the screen. Now, we are doing something different and interesting by working with scale animations. Instead of moving emojis around with X and Y like before, we are playing with size using the scale property. Initial is equal to scale 0. This means when the emoji first appears, it starts off as completely invisible or tiny, basically shrunken down to nothing. Animate is equal to scale 1. This line makes the emoji grow to its full size, giving it a nice popping in effect. Exit is equal to scale 0. And when the emoji disappears, it shrinks back down to nothing, making it look like it vanishes smoothly. Const restart game function. We are basically setting up a way to reset our game back to the beginning when a player wants to play again. We are defining a function called restart game. This function will be called whenever we want to completely reset the game and start fresh. setTimeLeft 30. Okay, so this line is super important. When we restart the game, we want the timer to go back to its starting point. Here, we are setting the time left state back to 30 seconds. It's like saying, alright, the game is starting again. Give the player a full 30 seconds to play. Set escape mover false. This line tells the game, nope, the game is not over yet, we are starting fresh. It sets the isGameOver state to false, allowing everything to work as if the game just began. Set emojis. This line clears out all the emojis currently visible on the screen. We are setting the emoji state to an empty array, making sure the screen is empty before new emojis start popping up again. It's like cleaning the game board before restarting. Set show win message false. If the player had previously won the game and saw the winning message, we want to hide that message now. This line makes sure we are not displaying the win message anymore when restarting the game. Set message. This resets the message displayed to the player. For example, if you had a message like, game over, or, you win, this line will clear it so the player can start with a clean slate. You can see the timer in seconds here. Now let's go and style our CSS part. Emoji class. Position, absolute. This line allows each emoji to be placed randomly anywhere on the screen. The position is controlled by the X and Y values from your JavaScript code. Font size, 2.5 rem. Sets the size of the emojis. They appear nice and big, making them easily clickable for the user. Cursor, pointer. When you hover over the emojis, the mouse cursor changes to a pointer, hand icon. This visually tells the user that the emojis are clickable. User select, none. This prevents users from accidentally highlighting the emoji text when clicking. Makes the clicking experience smoother and cleaner. Transition, transform 0.2s. This adds a smooth transition effect when we apply transformations to the emoji. The emoji will grow or shrink in a smooth animation instead of a sudden jump. Emoji, hover class. Transform, scale, 1.3. This makes the emoji grow by 30% when the user hovers over it. The smooth animation from the transition property ensures it feels playful and engaging. What's the output? Emojis appear on the screen randomly and are easily clickable. When you hover over an emoji, it smoothly zooms in, growing by 30%. This visual feedback makes it more fun and satisfying for the user to click on the emojis. The pointer cursor also makes it clear that the emojis are clickable. If score is equal to difficulty settings, difficulty, win score and show win message. First, we are checking if the player's score is high enough to win the game. We compare the score with the winning score for the chosen difficulty level. Also, we make sure the win message is not already showing. Basically, did the player win the game and haven't we shown the win message yet? Set show win message, true. Now, we are setting the win message to appear. It's like telling the game, okay, show the player they won. Set as game mover, true. We are setting the game over state to true. This stops the game from running further. Set message. We are showing a win message to the player. The message will be green with a celebration emoji party popper and will say something like, you won. You scored X points. If score high scores, difficulty. Now, we check if the player's score is higher than their previous high score for that difficulty. If yes, it means they broke their previous record. Const new high scores is equal to high scores, difficulty, score. This line is creating a new high score list with the updated score. It's like saying, let's save this new record without losing the other difficulty scores. Set high scores, new high scores. This line updates the high scores to remember the player's best score. Basically, save the new high score so it shows up next time. Return. We are stopping the code here if the player has won and their score is saved. It's like saying, alright, we are done with this part, don't run anything else. Const, spawn rate, lifetime, is equal to difficulty settings, difficulty. This line is picking the speed and lifetime of emojis from the settings based on the chosen difficulty. It's like, get me the speed of the emojis and how long they stay before disappearing, based on the difficulty level. Now we are adding to generating a special emoji chance. Const is special is equal to math.random, 0.1. We are creating a special emoji randomly. Math.random gives a number between 0 and 1. If it's less than 0.1, 10% chance, then a special will be true. Then add this line to symbol is special, crown, emoji list, math.floor, math.random, into emoji list.length. This line decides what the emoji looks like. If a special is true, the emoji will be a crown. If not, It randomly picks an emoji from our emoji list. Now go to Google and copy the crown emoji and paste it here. This is called dependencies list, time left, difficulty, score, shown message, high scores. The use effect will run its code whenever any of these values change. It helps keep track of things like score updates, difficulty changes, or when the timer hits 0. Now let's add this. The handle emoji click function. Const handle emoji click is equal to ID, symbol, points, is equal to. This function runs whenever you click an emoji. It takes three things: ID, unique emoji ID, symbol, the emoji itself, and points, how many points it's worth. Checking if the game is over. If is game over. This line makes sure you can't click on emojis when the game is over. If the game is over, nothing happens when you click. Marking the emoji as caught. Set emojis. Prev is equal to prev.map. Emoji is equal to emoji.id is equal to id. Or emoji. Caught. True. Emoji. This part updates your emoji list. It marks the clicked emoji as caught, so it can be removed from the screen. Emoji. Caught. True means it copies the emoji's details but changes caught to true. Checking for the bomb emoji. When we restart the game, we need to reset the winning status and messages to ensure the game starts fresh. What we added. Set show win message, false. This ensures the win message is hidden when we restart. Set message. This clears any text messages like, you won, or, game over, to make sure you start fresh. Checking for the bomb emoji. If symbol is equal to bomb. This part checks if the emoji you clicked is a bomb emoji, bomb. If it is, it sets the game as over and shows a game over message in red, displaying the bomb message. Set message. Span style is equal to color, red, bomb or no. You clicked the bomb emoji. Game over. Span. This shows a message saying you lost the game because you clicked the bomb. It changes the text color to red to make it obvious you lost. Finding the clicked emoji. Const clicked emoji is equal to emojis.find, emoji is equal to emoji.id is equal to id. This finds the emoji you just clicked from the list of emojis on the screen, increasing the score. If clicked emoji and clicked emoji.caught. Set score, prev score, is equal to prev score plus 1. If the emoji isn't caught yet, you clicked it for the first time, then it adds points to your score. The score increases by 1, unless it's a special emoji worth more points. Why this code is important? It detects clicks, updates the score, and shows messages when a bomb emoji is clicked. It keeps track of emojis and makes sure you can't accidentally click the same emoji twice. Const width height is equal to use window size. We are calling use window size and using destructuring to extract the width and height properties. It automatically tracks the current window size and updates whenever the window is resized. Here we imported use window size from a library called reactUse. Now after adding all suitable emojis, now let's see our output. You can see here after our time runs, it's showing time over message in red color. Even when we accidentally click bomb emoji, it displays a message, or you click the bomb emoji play again message. Now let's add our CSS styling part. Game over. Text align, center, margin top, 20px. Animation, fade in 0.5s. Text align, center. This centers all the text and content inside this game over area. Margin top, 20px. Add some space from the top to the game over section, so it's not too close to other elements. Animation, fade in 0.5s. Makes the game over message fade in smoothly when it appears, which looks more visually appealing. In the output we can see, when the game ends, this whole section appears nicely in the middle of the screen with a smooth fading effect. Game over H2. Font size, 2 rem. Color, DC 143C. Font size, 2 rem. Makes the game over text big and noticeable. Color, DC 143C. Gives it a dark red color, making it look like a serious or warning message. In the output we get, the game over text is big, bold, and dark red, making it immediately catch the player's attention. Game over button. Padding, 10px 20px. Font size, 1 rem. Margin top, 10px. Cursor, pointer. Background color, Hush FF69B4. Color, white. Border, none. Border radius, 5px. Transition, background color 0.3s. Padding, 10px 20px. Makes the button larger and easy to click by adding space inside it. Font size, 1 rem. Sets the text size to be readable. Margin top, 10px. Add space between the text and the button so it's not crammed. Cursor, pointer. Changes the cursor to a pointer when hovering over the button, showing it's clickable. Background color, Hush FF69B4. Makes the button pink, making it look fun and playful. Color, white. Keeps the button text white for good contrast. Border, none. Removes the default border to keep it clean looking. Border radius, 5px. Adds rounded corners to make the button look smoother. Transition, background color 0.3s. Adds a smooth color change effect when you hover over the button. Output, the restart button appears with a pink background, white text, rounded edges, and a smooth color transition when hovered. Game over button, hover. Background color, Hush FF1493. When you hover over the button, the background changes to a darker pink, Hush FF1493. The transition makes the color change feel smooth and attractive. Output, the button changes color when you place the mouse pointer over it, making it feel responsive and interactive. At keyframes fade in. From opacity, 0 to opacity, 1. This defines an animation called fade in. It gradually changes the opacity from 0, completely invisible, to 1, fully visible. Output, when the game over screen appears, it fades in smoothly instead of just popping up suddenly. What happens in the end? When the game ends, a big red, game over, message appears smoothly in the center, with a pink button below it. The button changes color when you hover over it, making it look nice and interactive. Everything feels smooth and well designed, not rough or awkward. At keyframes confetti fall. 0% transform, translate Y, 100 VH, rotate, 0 deg. 100% transform, translate Y, 100 VH, rotate, 360 deg. This creates an animation called confetti fall. 0%. The confetti starts above the screen, outside view, 100 VH, and doesn't rotate. 100%. The confetti falls to the bottom of the screen, 100 VH, while spinning in a full circle, 360 degrees. This makes the confetti fall and spin as it moves downwards. In the output we can see, confetti pieces fall from the top to the bottom of the screen while spinning around. Confetti. Position, absolute. Width, 10px. Height, 10px. Background color, red. Animation, confetti fall 3's linear infinite. Border radius, 50%. Position, absolute. Allows each confetti piece to be placed anywhere on the screen. Width, 10px. Height, 10px. Makes each confetti piece a small square or circle. Background color, red. The default color for confetti is red. Animation, confetti fall 3's linear infinite. Applies the falling animation. It takes 3 seconds to fall and repeats forever. Border radius, 50%. Makes the confetti look like small circles instead of squares. Our output looks like red confetti pieces falling down the screen forever. Confetti. N child, 2N. Background color, blue. Changes the background color to blue for every even-numbered confetti piece. 2nd, 4th, 6th, etc. Output. Blue confetti pieces fall down along with the red ones. Dot confetti. N child, 3N, her background color, yellow. Changes the background color to yellow for every third confetti piece, third, sixth, ninth, etc. Our output is like, yellow confetti pieces fall down, making it colorful. Dot confetti. N child, 4N, her background color, pink. Changes the background color to pink for every fourth confetti piece, fourth, eighth, 12th, etc. Output. Pink confetti pieces are added to the mix. Dot confetti. N child, 5N. Dot confetti. N child, 5N, her background color, orange. Changes the background color to orange for every fifth confetti piece, fifth, 10th, 15th, etc. Your output. Now you also have orange confetti falling. What does this code do overall? This code creates a colorful confetti rain effect. Small round pieces of confetti in red, blue, yellow, pink, and orange fall from the top of the screen to the bottom, spinning as they fall. The animation is endless, so it keeps repeating. Oh, you can see how beautifully it's giving congratulations papers falling from top. Now open app.css file and delete current code and start fresh by adding this code. Body. Margin, 0. Padding, 0. Font family, Arial, sans serif. Margin, 0. Removes all default space around the edges of the web page. Padding, 0. Removes all default space inside the web page's body. Font family, Arial, sans serif. Uses the Arial font for text. If Arial is not available, it picks a basic, clean font instead. Our output looks like. The whole page looks cleaner with text using a standard Arial font and no extra space around it. Game container. Text align, center. Padding, 20 px. Min height, 100 vh. Text align, center. Aligns everything inside this container to the middle of the screen horizontally. Padding, 20 px. Add some space inside the container to keep the content from touching the edges. Min height, 100 vh. Make sure the container always takes up the full height of the screen, even if there's little content. And our output is like, the game area is centered, has some space inside it, and stretches to cover the whole screen vertically. So, that's it for the emoji catcher game. I hope you enjoyed this fun and simple mini project. It's a great choice for freshers who want to build something cool and showcase their React skills. You can customize this game, add more features, improve the UI, or even turn it into a multiplayer game if you want. If you found this helpful, make sure to like the video, share it with your friends, and subscribe to the channel for more exciting mini projects and tutorials. And if you try building this game, let me know in the comments. I'd love to see your versions. Thanks for watching, and happy coding!